Example 3, determine if each relation is a function, give the domain and the range. I think the easiest way to do these problems is by graphing, all right? Sometimes if you can just visualize what the graph looks like, you've got everything that you need. So we look at the first example, 2x minus 5. You might be able to visualize that, or let's check out Desmos. All right, check out that graph. Think about the vertical line test. Is that a function according to the vertical line test? Yeah, right? Sure. Okay, so what we have, graph looks like this. Vertical line test shows me that that is a function. And then give the domain and the range, the domain being the x numbers. So think about a line, all right? If I'm a line and that line goes on forever to infinity, if I squash that line, it's going to cover the whole x-axis. The whole thing is covered, so what does that mean the domain would be? All real numbers, right. Negative infinity to positive infinity. Well, likewise, the range, if you squash that thing onto the y, it's going to cover everything vertically. It's going to cover all of the y numbers. So the range is also negative infinity to positive infinity. That will not always happen. It will not always be all real numbers. Moving on to the next one, x squared plus 3. Ideally, you just know what that looks like because you've seen that pattern before. Okay, do you know what shape that is? If you don't, x squared plus 3 looks like a parabola that's been shifted up, 3 specifically. So we've got this shape right here. Looks like that. Vertical line test, is that a function? Yeah, that's gonna work. That's a function. So then domain and range, think about squishing it. If you squish that parabola down onto the x, it's going to cover everything. So the domain would be all real numbers. However, if you look at the y numbers, the range, you're not going to cover the whole y-axis. You're only going to cover from 3 up. And so your range is going to be equal 3 to infinity. Now remember, if you could equal that number, it's going to be a square bracket. If you can't equal the number or don't equal the number, it's going to be a parentheses. Next one, y is greater than or equal negative x. So let's look at what that one looks like. Y is greater than or equal negative x. Okay, so that's got some shading on there. Shading. I think this one tricked some people last period. But if you look like this, and you got this with some shading, you look at that vertical line hits a lot of points. It doesn't just hit there. It hits everything that's shaded in. It hits a lot of points. This is not a function. It doesn't pass the vertical line test. We can still do domain and range, though. Domain, when I squash it onto the x, everything's covered. All real numbers. When I squash it onto the y, everything's covered. All real numbers. Next one, x equals absolute value of y. You might not know what this one looks like. X equals absolute value of y. Okay, check it out. It's like a V shape on its side. Does that pass your vertical line test? It does not. So this is not a function. If you're squashing it onto the x, if you're just looking at the x numbers, it's only covering that part of the axis. Okay, from 0 to infinity is the domain. Equal 0 to positive infinity. The range is going to cover everything on that y. If you squash it on the y, it covers everything. That's all real numbers, negative infinity to positive infinity. Last one of this set, 3 over x plus 2. All right, so that's a funny looking one. This one has an asymptote. An asymptote specifically at -2. So check out the graph. We were going to draw a sketch of that. It looks kind of like this. Okay. So it looks funny, and your gut probably tells you that this is not a function. But if you imagine that vertical line, the vertical line test is going to cross once. Right in the middle here, it doesn't touch at all. That's 0. And then once. It only ever touches the graph one time. And if it only touches the graph one time, that means it is a function. So I know this one looks weird, but this one is a function. So then the domain and range is tricky because this graph is in 2 parts. Okay, it's not continuous. You would have to pick up your pencil to trace it. But think of this as 2 parts. If you squash the left part onto the axis, you would basically have this. You would have everything up to -2. So think of that part as from -infinity to -2 with a parenthesis because you won't equal the -2. There's a hole there. But then if you look at the other part, you're going to pick right up there at that -2 and cover everything else to the right of that. So you would have from -2 to +infinity like that. The only thing missing, we would put a letter U in between there. U stands for union. Union means to join. We're joining those 2 pieces or those 2 intervals. So with the range, we do kind of the same thing. If you squash that left piece onto the y-axis, you're going to have this, and there's going to be a hole in the middle. And then the other piece, you're going to fill in this part. So it's almost all real numbers. It's all real numbers except that missing piece in the middle there of 0. Remember, we're looking at y numbers now, not x numbers. So we're going from -infinity to 0, not equal to though, unioned with 0 to infinity. Number 4, evaluate each function. Basically, we're just plugging junk in. I put this first one on here because everybody messes this one up. If you plug in 5 into the f function, -5 squared minus 6 times 5 plus 4. A large number of people mess this up, okay? But think about it. Am I squaring the negative in this problem? I'm not. I'm not plugging in -5. -5 is not getting squared, just the 5 is. All right, so we don't really read this as -5 squared. We read it as the opposite of 5 squared. That's going to be -25 there. Everybody messes that up, so be very careful. -30 plus 4. This is just an order of operations problem. -55 plus 4 is -51. So f of 5 equals -51. Now, I know you've done that problem a lot. I just wanted to point it out because it's a common mistake. The next one is actually much easier. Plug in a letter. You would get, okay, let's plug in b for x. You're going to have -b squared minus 6b plus 4. There's nothing else to do there. That's it. So then notice the next one, g of -4. You're plugging into a different equation. You're plugging into the g equation this time. So it says 3 times the number plus 1. That's -12 plus 1. That's -11. G of -4 is -11. Then the last one, plug in c plus 2. So yeah, I guess that's kind of weird. You're plugging in an algebraic expression, a binomial. But remember what the g function does. The g function says 3 times something plus 1. So we're going to plug in that c plus 2. And we can distribute here. You get 3c plus 6 plus the 1. Add the like terms. You get 3c plus 7.